All right. Hi, everybody. Welcome back. Today I'm going to talk about trig. You might be taking pre-calc and have to do a lot of trig, or algebra 2 with trig. Kind of comes at the end of algebra 2, but a lot at the beginning of pre-calc. And I'm going to share some problems here. Going to do it a little bit out of order, but start with number 2. Okay. 5 remaining trig functions of, so that little circle with a line through it, that's math jargon for basically an angle. So whoops, turn on my pen here. Theta is that symbol there. That's what that means. So one of the first things that everybody learns, and don't forget it, is SOHCAHTOA, right? SOHCAHTOA is sine, cosine, tangent. And if we were talking about a right triangle, so we're always talking about right triangles, unless you get to a section called the law of sines and cosines. It doesn't have to be a right triangle, but this stuff does. So we're always talking about right triangles at the beginning, and let's just say that one random angle here, that's theta, okay? So the side across from it, that's going to be my opposite side. The side nearest, that's my adjacent side. And then the long side, the easiest way to think of it is the side across from the right angle. That's called your hypotenuse. So SOHCAHTOA is a play on those sides. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I know this sounds super abstract, and maybe even maybe you've never heard of it, but you're going to use this a lot. SOHCAHTOA is like one of the most heavily used acronyms in trig. So there's SOHCAHTOA, and the other 3 are cosecant, secant, and cotangent. I really wish that whoever made these a long time ago had paired cosine with cosecant, but it's, everything in math, like 90% of stuff in math is like backwards. So sine actually goes with cosecant. So like, I'll write them down here. Sine actually goes with cosecant. And then cosine actually goes with secant. And these are the same things I'll explain as earlier with the opposite, adjacent, hypotenuse thing. And then luckily, cotangent goes with tangent. Kind of wrote those backwards. It's okay, they're opposites of each other. And a cool way to remember this, I think it kind of sounds like a real word, maybe like a martial arts move. So you got SOHCAHTOA. All you do is change those letters backwards, and it becomes cho, sha, cow. Cho, sha, cow, right? Kind of sounds like a martial arts move. So let's now look at the question they've given us. Find the 5 remaining trig functions of theta. And they tell us that sine of theta is -1 over 5, and cosine is greater than 0. First, there's a lot of information, and don't worry about knowing all of it at once, but cosine greater than 0 is like an important parameter. That means that we are, how to explain, if we've got an axis here, so cosine is always the x-axis. That means that we're in this area, and we are not in the left side. So we're not on the left, we're in the right side of the axis. And we're going to draw a triangle different color here. It's going to be some sort of triangle that looks like this. And our theta is somewhere like this. So it's telling us that sine is -1/5. Well, sine under SOHCAHTOA, so sine is -1/5, and that is equal to opposite over hypotenuse. Well, if it's -1/5, opposite over hypotenuse, well, this might be, so we have to look at the triangle. Is it the upper one or is it the lower one? This is where you have to make the choice. Well, in the upper one, we've got a positive side and a positive side. Like if you're on an axis going right and up, those are positive and positive. The only way to have a negative is the bottom triangle, which is right and then down. That can be -1, and then this hypotenuse is 5. So I know that sine of that angle theta is -1/5. Now I'm going to delete everything, but I'm going to redraw the triangle as we need it. So we have boom, boom, boom. This is -1. This is 5. This is my theta, and there's a right angle. We have to do Pythagorean theorem to get this final side. So it's going to be, let's just call it x right now, because we can figure out what it is. Pythagorean theorem says one side squared plus another side squared is equal to the third side squared. But the third side is always the hypotenuse. That's a must. It's got to be the long side by itself. So x squared, well, -1 squared is just -1 times -1, which makes 1. And then 5 squared is 25. We'll subtract the 1 over, we get x squared equals 24. And then we square root both sides. What do we get? X is equal to square root 24. Well, let's see if we can break that down. Are there any perfect squares that go into that? There's 9, no. 16, no. But I know that 4 does. 4 and 6. So 4, 6. We know the root 4 is a real number. It's 2 root 6. So our x up here is 2 root 6. So again, to keep some space, we've got 2 root 6, -1, and 5. We know that sine is -1/5. Let's do cosine, which is, so let's write at the top again, SOHCAHTOA and sha, cow. Cosine is adjacent over hypotenuse. So our angles right here, adjacent is 2 root 6 over hypotenuse. So 2 root 6/5. Tangent, opposite over adjacent, -1 over 2 root 6. Can't have a square root in the denominator, so we'll multiply that root 6 out. We get -√6 over 2 times 6, which is 12. And then cosecant. Okay, so these ones, there's 2 ways to think about it. You could do the SOHCAHTOA, which is like hypotenuse over opposite, or you can just flip the sine, cosine, and tangents, because they're all like reciprocals of each other. You take the fraction and you flip it. So cosecant, secant, and cotangent. Cosecant is, so sine is -1/5, so the other version flipped is -5/1. You don't change the negative positive, you just change the numbers. Then secant would be 5 over 2 root 6, but again, you can't have a square root in the denominator, so the top is 5 root 6. And the bottom, so when you do root 6 times root 6, you actually end up just getting 6. So it'd be 2 times 6, which is 12. And then finally cotangent. Well, we know that tangent is -1 over 2 root 6. So it'll be -2 root 6 over 1, or -2 root 6, because anything over 1 can just be written as is. So I'm actually going to circle or box every answer. This one, this one, this one. All right, so we'll start with that. Rewatch the video to make sure that you understand that it's asking the 5 remaining trig functions, meaning all 6. We've got sine, cosine, tangent, cosecant, secant, and cotangent. And 1, 2, 3, 4, 5, 6. It's all of them. Kind of a recap. If they tell us sine, that means they're telling us opposite over hypotenuse. So I just make a right triangle. Oops, gotta add it in there. Opposite's right here, hypotenuse is right here. But to know where the negative goes, that's where they give us that parameter. And cosine always means the x-axis, so if it's positive, this has to be in the like right side of the origin here, so it's in the positive part of the x-axis. So hope that helps, and I will continue to make more videos as I come up with problems, and good luck with math this year.